in precipitation, talking about solubility. All right, solubility rules. So, will a reaction happen? Because, I mean, you could take two soluble salts, you mix them together, and they just stick around in solution. There's no reaction there. The only way there's a reaction is if you have at least one insoluble product. If all your products are soluble, then they're all spectators. Okay, nothing happens. There's no reaction. So in order to predict a precipitation reaction, we need to know our solubility rules. First up, you have ions that are always soluble. Those are the alkali metals. Okay, the first column over here. These guys will always, always, always be soluble in water. Okay, lithium, sodium, potassium, rubidium, cesium, and technically francium. Okay, always, always soluble. Also, ammonium, NH4+. Okay, you see something combined with ammonium, it will always be soluble in water. And then for our negative ions, nitrate, chlorate, and acetate. Or sorry, not chlorate, this is perchlorate. NO3 1 minus, ClO4 1 minus, CH3COO 1 minus, or C2H3O2 1 minus. Remember, there's different ways of representing acetate. So if you see one of those in a salt, it doesn't matter what they're partnered with, then that salt is soluble in water. Okay? Some ions are always soluble, some are almost always insoluble. But no matter what, if they're paired with one of these guys, then that compound is soluble in water. Now, these ions are usually soluble, but they have a few exceptions. Okay? So chloride, bromide, and iodide, almost always soluble, right? Except if they're partnered with silver, mercury 1, or lead 2. Okay? So silver chloride, silver bromide, silver iodide, all insoluble. And in fact, they were really popular with early photographers. They were the early photographic compound. Mercury 1 chloride, mercury 1 bromide, mercury 1 iodide, lead 2 chloride, lead 2 bromide, lead 2 iodide. Those are all insoluble. Meaning that if you produce this, it'll come out of solution as a precipitate. Sulfates are usually soluble, but they have exceptions as well. So if sulfate is paired with strontium or barium, the result is insoluble. If it's paired with mercury 1, it's insoluble. If it's paired with lead 2, it's insoluble. Okay. So again, if sulfate is paired with any of these four ions, then it will fall out of solution as an insoluble solid as a precipitate. Now, these guys are usually insoluble. So carbonate and phosphate, okay, are usually insoluble. The most common form you find carbonate in, or at least you're likely to encounter carbonate in, around here anyway, is limestone. This is what is responsible for hard water. Because it'll like the teeny tiny little fraction of it as the water runs through the limestone aquifers, you'll get a teeny tiny little bit of this calcium carbonate, and then it comes out of your faucet and it ruins your soap, and it will actually plate the inside of your pipes and so on with limestone, and it's a real pain in the keister. People hate it. All right, so carbonate and phosphate, insoluble, unless they're paired with the ions that are always soluble. That's going to be the big exception. Remember, these guys are always soluble. So sodium carbonate, lithium carbonate, ammonium carbonate, always, always, always going to be soluble in water. Phosphate likewise, usually insoluble unless it's paired with one of the always guys. Sulfides and hydroxides are also usually insoluble, okay, unless they're paired with the always soluble guys, so sodium sulfide, sodium hydroxide, or with the heavy alkaline earth metals, so calcium, strontium, and barium. So beryllium and magnesium don't count as an exception, but calcium, strontium, and barium do. The three heavy boys. The light boys, they don't do nothing, but the heavy boys, they do. Calcium, strontium, and barium will render those guys soluble. Okay. not incredibly soluble, but still somewhat soluble. So calcium hydroxide, you have almost certainly encountered that. That's Tums. That is your antacid. It's a nice strong base. It'll react with the acid in your stomach. It'll neutralize it a little bit. So if you're having an upset tummy, then that's why it helps. All right. So does a reaction occur? What you do is you take these guys, you swap the partners, and then you look back at the solubility rules and you see, do I have an insoluble product? If you don't have an insoluble product, then no dice. It just doesn't work. Okay. Why do I have fluoride on there? I didn't talk about fluoride. I should change that. So what I'm going to do is I am going to change that right now. Actually, I'm also going to check the textbook before I get too up in my head. Does the textbook almost certainly does talk about. It absolutely does talk about. I need to go back to the beginning of chapter 7 because I want to make sure I'm giving you all the information that they're going to expect you to know on the test, and the textbook is my guideline for that. No, they don't mention fluoride at all. Okay. Good. So you're not going to be expected to know. There are special rules. Fluoride is its own separate category of ionic compound. So I'm definitely going to go in. I'm going to remove the fluoride. I'm going to replace it with, not hydroxide. I'm already using hydroxide. Let's go with, carbonate. Yeah. All right. So they swap their partners, and then you look at the products to see, does a reaction occur? Do we get an insoluble product? Okay. Go ahead, take a break, or pause. Don't take a break. And if you need to remember the rules, there's a table on page 242 that gives you the different ions. There's also a more condensed version that matches pretty much exactly what I said earlier. Yes. Yeah. This gives you the solubility rules that I mentioned earlier. All right. So, does a reaction occur? Go ahead, pause it, give it a shot. I'll be waiting for you when you come back. I'll go through them all. And welcome back. So, we have sodium chloride and lead 2 nitrate. NaCl plus PbNO3 2. We're going to need 2 of those. I'll tell you that for free. NaNO3 and lead 2 chloride. So now the question is either of these insoluble? Okay. We go back to our rules and we look and we see sodium is always soluble. So is nitrate. So this guy here, he's getting a double whammy. He is always, definitely, absolutely going to be highly, incredibly soluble in water. Lead 2 chloride. Well, chloride doesn't show up on any of our always solubles. In fact, it shows up on our usually solubles. So that means this is, lead. Lead 2. So lead 2 chloride is insoluble. So insoluble means it comes out of solution as a solid. So this time, yes, we do get a reaction. Moving forward, sodium carbonate and ammonium chloride. So Na2CO3, it's going to be aqueous, plus NH4Cl, also aqueous. So again, we just swap the partners. So we're going to get 2NaCl plus NH4 2CO3. So sodium chloride and ammonium carbonate. Well, we remember from the previous one, sodium is one of our always solubles. So sodium chloride, yeah, from experience, you should know that's soluble in water. What about ammonium carbonate? Ammonium close this guy. Uh-oh. Carbonate is usually insoluble, except for the always is. So we're going to have to check the always is. Ammonium is always soluble. So, excuse me. So that means that even though carbonate is usually insoluble, because it's paired with ammonium, ammonium carbonate will dissolve, not a problem. So AQ, ammonium carbonate is soluble. So that means we look at this. All these things are aqueous. So all these things are just ions in solution, which means that everything here is a spectator ion. If you were to break this up, you would have 2Na plus CO3 2 minus plus 2NH4 plus 2Cl minus going to form 2Na plus 2Cl minus plus 2NH4 plus CO3 2 minus. Okay, so they'd all be floating around in solution. They would all be spectators. Nothing is changing. Everything is the same on either side of this reaction. So if everything's the same, if nothing's changing, no reaction. Nothing is happening. You just took a bottle of liquid, you mixed them together, and you have more liquid. Boring. Who cares? No reaction. Finally, we have calcium hydroxide and potassium carbonate. So, calcium hydroxide is CaOH2, aqueous. Remember, hydroxides are usually insoluble, but calcium is one of the exceptions. And then we have potassium carbonate. Again, carbonate is usually insoluble, but potassium, it's always soluble, so that means it's an exception for carbonate. So when we swap the partners, we get calcium carbonate and 2 potassium hydroxides. So potassium is still one of the always solubles, so potassium hydroxide, nice and soluble. In fact, that is one of the forms of lye, caustic lye, known as potash. And then we have calcium carbonate. So we're going to have to look at the rules for calcium carbonate again. So carbonate, usually insoluble. The exceptions are the alwayses. And it's only with the alwayses. So calcium carbonate is not an exception. So calcium carbonate is solid. In fact, that's what I was talking about earlier, that limestone. So you're going to have to be careful about that. Because as we see here, sulfides and hydroxides, they will be soluble if paired with the heavy alkaline earth metals, calcium, strontium, and barium. But carbonate and phosphate don't have those three exceptions. Okay? Calcium or carbonate and phosphate are only soluble if they're paired with one of the alwayses. Okay? Sulfide and hydroxide, the alwayses, and those three. So this is a lot to memorize. It's going to be a real pain in the keister. You should make up flashcards or something. I don't know the best way to make up flashcards for this, but you should. You absolutely should work on this. Because they will be asking you about it in lab and on all the tests moving forward. This is going to be a big deal. Okay, so that does it for this particular set of slides. We are done with talking about solubility solubility rules, which means we're done talking about precipitation reactions. Those are what they can ask you about for precip reactions. They can ask you, does a reaction occur? Write the net ionic equation. And then they could ask you to do stoich work with it. Nothing too new there. All right. So I'll see you at the next set of slides in just a couple of minutes.